To start, I want to briefly walk through what the exact steps of bootstrapping are and how that's going to happen in R. And then I'm going to talk about exactly what we're getting out of those bootstraps. And finally, in the next module, then we're going to talk about how to implement that more efficiently with a specific package in R. So to start, we're going to assume that we're going to take a representative sample from the population. So we're going to use about a fourth of our total N here. In that case, it's going to be about 50. And what we're going to do, right, is when we resample, this is going to be giving us an empirical sampling distribution from R. So we're going to do sampling with replacement. And one observation, right, is going to have one X, it's going to have a reported weight, it's going to have one Y, a actual weight, and we're going to get an estimate finally of the correlation coefficient. So in R, this looks like, again, we're going to set our seed. In this case, I'm setting our seed to 1, 2, 3, 4, 5. We're going to create an empty vector with which we're going to store the correlation coefficient, right, from each round in the bootstrapping. And here, what I'm doing is what I did in the previous slide. I'm taking a sample of size 50 to be determined by the user in this function. And I'm going to then take the correlation of the first variable, and in this case, reported weight, then the second variable, actual weight, and then that's going to store that correlation coefficient in our empty vector, right? So when we return that vector of correlation coefficients, that should be of length k, which in our case is going to be 50. We're going to run 50 iterations, right? So what that looks like, or sorry, in this case, I'm going to be running 100 iterations, and for each of those samples, we're going to have 50 observations. Now, when we plot this, we can see that we're getting a pretty wide variation, right? And so we're probably one solution would be to increase the number that are sampled in each of the iterations, or in conjunction with that, we could increase the number of bootstrap samples, right? Now, what are we going to do once we have an actual distribution for the sampling distribution of that correlation coefficient, right? Well, we're going to want to try to do exactly what we did when we had a, quote, sampling distribution of that mean from in the same way that we generated it when we had assumptions, right? We're going to want to make confidence intervals, and that's going to allow us to make hypothesis tests. So we're going to essentially look at if we want to create, right, a 90% confidence interval, we'd look at the fifth percentile at the bottom, the top fifth percentile at the top, right? And that's going to be our confidence interval. And we're going to do the exact same thing that we would have done in a parametric model. Again, importantly, this is only going to work though if the original sample is representative of the original population. Importantly, we should resample our sample in the same way that the original data was sampled. So here we're doing simple random sampling, and we're assuming, right, that our data originally was generated from just simple random representative sampling. So just like correlations, now we can go ahead and do this for estimated coefficients and regressions, and that's what we're going to be doing in the next module.